My talk today is The Art of Performance Monitoring, which is definitely an overly ambitious title for what I have to talk about, but those can be pretty fun. So I work on the monitoring team at Facebook, and the way that the things seem to be going outside in the industry is that like you have a centralized monitoring team that like builds tools, and then you help the other teams build monitoring, and that's exactly how our team works, which is that we build the tools and systems that team use to build their monitoring. This talk is like actually sort of like a whole bunch of diverse experiences. It has like one central narrative, and you know what, let's just get into it. All right, so what I'm going to start with is I want to define a couple of the like key problems that I see people repeating over and over and over again when they build their monitoring, especially when you have a team built the way that Facebook's monitoring team is built. It's very easy for new teams or inexperienced engineers to repeat these mistakes because they seem like good ideas when you're doing them. And the first one that I'm going to talk about is what I call high cardinality alarms. And these are like really simple once you kind of have a name for it. It's any alarm where if you have 100 machines or 100 objects or 100 whatevers, you can get 100 notifications simultaneously. And as I'm sure we all know, we have all been probably woken up in the middle of the night with a flood of the pager, and you're like, what the hell just happened? These are bad for one reason. You can't see the forest for the trees. Because when you have 100 disk-full alarms, you might miss the database overloaded alarm, which is the true problem. The next one is what I call reactive alarms. These ones are much more insidious and much more subtle. There's no good diagram for reactive alarms, it's just a person sitting there. What reactive alarms lead to are alarms that fire for conditions that no longer exist or that are no longer relevant in your service. And they're so insidious because they seem like a good idea, but they aren't. And here's how they happen. You are going along, running your service, everything's fine, everything's hunky-dory, and then someday you have a problem. And it's a big issue. It causes a huge outage, causes lots of customer downtime or internal frustration or whatever it is. And then you go to your company's version of incident review and you talk about it, and people say, well, what are you going to do about this? And of course, we all want to learn from our mistakes. We all want to like be proactive. And so we think, I will make an alarm for this condition. That way, I'll know that it's going to happen before it happens next time. And that choice is a totally reasonable choice to make. Except that you then accumulate these over months or years, and you find yourself in a place where experienced on-calls are training new on-calls saying, no, that one, you can just ignore it. It fires sometimes. We thought about deleting it, but it might tell us a real thing someday, so we're just going to leave it. I can tell that resonated with a few people. The moral of this one is don't be afraid to delete things, really. And the next problem, and these are really just sort of like the top three that I've seen, is what I call tool fatigue. And tool fatigue is when you have too many or too few tools, and it causes basically the same problem, although with different reasons. If you have too few tools, you spend all of your time figuring out how to write a crazy bash one-liner to get you the information or fix the problem that you have. And if you have too many, you spend all of your time looking for the right tool rather than solving your problem. I think the biggest example of this problem everywhere I've worked, including at Facebook, is what I call the on-call run book, where it's like, oh, one time Fred or Jane saw this problem and they came up with this cool one-liner, let's put that in the run book so the next time we see it, we just copy and paste that and then modify its arguments because the conditions have changed and we need to filter some more things. And then you take a step back and you kind of think about it and you're like, my God, this is the worst tool I could have designed. You run it by copying and pasting its source, and you change its arguments by modifying that source. And I think that the only reason we stand for it is because, well, it's just shell, right? But if you think about it, shell is every bit of a programming language as C++ or Python or Go or anything else. And you absolutely wouldn't stand for it if somebody was like, yeah, just copy and paste this bit of Python over there and it'll do what you want. At least I wouldn't stand for it. The thing that all of these have in common is that they're mechanical, simple, and obvious. Which is that at each moment you're like, oh yeah, I should make an alarm for disk full on my web servers. That makes total sense to me because I don't want to run out of disk. And you're like, I had an incident, so I should make an alarm for that. And you're like, I need a tool to do this, and so I'll put it in an on-call wiki. And at each step, you're making the most rational choice you can make. And so you don't realize that as you walk forward, that the cumulative effect is something that's really hard to maintain and kind of unbearable sometimes. And so with a little forethought and what I hope will be interesting practices that we've come up with, can make your monitoring much better. I know we've talked a few times about Scribe externally. Has anybody heard of it? Oh, wow, a whole bunch of you. Okay, so I'm going to gloss over all of the really interesting technical details about it. All you really need to know is that it's a high throughput, low loss message bus. And it's got a pretty simple API. You just instantiate a client and anybody can write messages from anywhere in the world. Nothing to do there. Its read client API is actually pretty interesting. It comes out of the history of how we built Scribe over time, but it's called PTail, stands for parallel tail. And you use it like a good old-fashioned Unix utility, which is that if you want to read your Scribe stream, you fork and exec this and then read it standard out. Which coincidentally makes it pretty easy to do debugging of your streams because you just run it on your machine and you get your stream out. Over the course of operating Scribe over 2.5 years, I used to work on the Scribe team. We came across a pretty fundamental problem, which is that as people were building more and more stream processing applications, they needed to know if they were processing their messages too slowly, if they were getting a backlog of messages that they basically weren't keeping up in their stream. And we had an answer for them, and hopefully, oh, wow, look at that. The lines actually show up. Can everybody see those lines okay? Yeah. Okay, well, I'll kind of point them out a little bit. Right around where we have this thing called backlog, there's a blue line that kind of goes up and down. And then right around where we have write wait, we have a green line that goes up and down. And it turns out that you can figure out whether or not your application is processing messages too slowly if you squint and kind of try to figure out which one happened before the other one. Maybe make some guesses. Maybe if you're really clever, do some time series division. We spent a lot of time on this. And it was mostly guesswork. Comparing these things was sort of an art, not a science. I realize I'm kind of a joke there. And more specifically, it was really hard to teach the customers of Scribe, other teams, how to do this interpretation, which meant that it all fell on the Scribe team. Every time a customer had a problem, they would come to us and be like, how do we debug this? So we came up with a new metric. And it was called write in progress. And it was really, really straightforward. It was a gauge that was 1 when PTail was waiting to write to standard out, and 0 all other times. To debug whether or not your stream processing application was too slow, you loaded up a chart, looked at the density, and you knew what the problem was. The moral of this story is that you shouldn't force yourself to do more work than necessary. One of the talks earlier talked about was observability, and how one of the key components of observability was making sure that you were measuring things precisely and accurately. This is exactly what I'm talking about. If you don't have specific metrics, you can't build robust monitoring on top of it. You should be able to describe in a few sentences what each one of your metrics means, and if you can't, you should seriously question whether or not that is a good metric. The other thing that having vague metrics does is it makes it harder to build automation. I know Signal FX and a number of other companies are doing a lot of really cool work in this area, but at the moment, it's pretty hard to do time series analysis. Like, our tools are relatively primitive. There's a lot of interesting research going on in the field still, but it's a pretty emerging field, despite having been around for a while. Its relevance has been increasing over time. And because of this, if you have metrics that you have to compose in order to get the answer that you want, it's much harder to build automation. You can't just say, hey, automation, when this thing goes to 1 for 5 minutes, do this action. You have to say, when the division of these things becomes greater than this ratio, it's a bad plan. I've tried it. Everybody with me so far? Have I said anything super revolutionary? Probably not. So there's really 3 components of what makes a good alarm, and this is really what I wanted to focus on, because the alarming and notifications are really what drive your experience of being on call for a system and determine whether or not you have the energy to actually iteratively improve it. If you are woken up constantly at 3 in the morning, if you are interrupted all throughout your day while you're on call, you can't actually spend the time to think about, how do I improve the system from the inside to move it forward so that you can stop having these problems. It can be very difficult to dig yourself out of this hole. So there's 3 components. Signal is more or less a proxy for the underlying metric. If your metric is precise and accurate and gives you good information about a specific condition, that's what Signal is for alarms. The next one is actionability. And this one's really straightforward. It's when you get a notification, can you do something immediately about it? And I don't mean stare at the pager, act the alarm, and go back to sleep. That is certainly doing something, but it's not something useful. The final one is relevancy. And relevancy, I kind of think of it a little bit like entropy. When you increase the relevancy of your alarms, you're increasing the total amount of information that each individual alarm gives you. Now, I kind of glossed over it a little bit, but there's really 2 kinds of alarms. There's alarms that are processed by machines and alarms that are processed by humans. The ones processed by humans I normally call notifications, and the ones processed by machines, well, I don't really care how many there are. A machine can chew through 1,000 disk-full alarms and do whatever you want in response to that condition, but a human can't. The single biggest thing you can do to improve the state of your on-call rotation and your experience of getting notifications is improve actionability. If you focus on that, you will wind up in a condition that is significantly better. I even have some numbers to show you. So on Scribe, we had a pretty terrible condition. Look at that, 2,600 minor alarms, all firing all at once. Not all of those went to email or IRC or anything like that, but a fair chunk of them did. So we worked on improving the actionability of our alarms. And we wound up killing about 97% of our alarms. We just went through and said, we don't know what this one means anymore, we're going to delete it. We don't know what this does, we're deleting it. We just very, very aggressively, and we trusted that if we deleted something that we actually needed, the system would give us that feedback by breaking and we wouldn't know about it. Because of the way Scribe was designed, we had a lot of single host alarms, and so it's kind of an exaggerated situation compared to what many of you might face. The moral of the story is that notifications that don't require human attention degrade everything else, and when we started focusing on this, Scribe could ignore the service unless an alarm fired, and then we knew that something was a problem and we had to act immediately. This was amazing because it allowed us to improve the state of the system and kind of get ahead of problems that we might be encountering rather than spending all of our time dealing with fires. Then we improved relevance. We took a step back and we said, what do we really care about from a customer perspective? What do our users care about? What are they observing when they are using Scribe that causes them problems? And it's end-to-end latency. When you get a message, you want to know how long it's going to take for it to come out the other side. So we wound up with about 1 alarm per layer of our stack. And it had the tremendous impact that when we got an alarm, we knew that we could ignore everything above it, because each alarm bisected the system and allowed us to direct our debugging experience very, very rapidly. In the extreme case, you might actually only have 1 alarm for your entire system. Well, 2, 1 alarm to tell you if your actual alarm is broken, and then your actual alarm. The final thing that I want to talk about, and this is really, really important, is that your dashboards are a debugger. They're not a passive tool. You don't write code without GDB or, what is it, PYDB? PDB is the Python debugger. You wouldn't write it without printf. You wouldn't write code without printf. Running a service in production is no different than this. And the way to think about this is that your metrics are live, active trace points inside your application that are continuously reporting the health of it. The design of a dashboard is every bit as important as the information that it has. And one of the things that we discovered is this, we came up with this concept of a dive dashboard. And so this is cubism. I don't know, has anybody heard of cubism? It's a square thing? Yeah. We took a cubism and we turned it into this like stacked view so that each one of these lines is like one stamped layer of our stack. So like, let's say we have like a right path layer. So that's each one of our right path layers, and that's a single metric representing all of them. The way cubism works, I'll briefly get into it, is that it's sort of, you define the acceptable range for a metric, and then every time that the metric goes above that range, you get darker and darker plots on the on each graph. Can anybody point out some problems on this graph? So a few on that, was that 5th line right there? Something's going on there. It's like kind of pretty repetitive spikes, right? So the way that we would do this is we would highlight that, and it would pull up a dashboard of all of our like more detailed metrics. And then we'd say, oh, this detailed metric is broken. And you highlight that and you drill down again until you basically have discovered the problem. This pattern wound up repeating itself over and over and over again across multiple teams once the idea sort of caught on. And I can't actually present anything like today about it, but hopefully we'll be able to show a little bit of like how we designed it in the future. I'm actually done. This talk is actually fairly quick. If you remember nothing else, remember Hamu. So let's see, my laptop is telling me I clocked in at 18 minutes. My favorite part of giving any talk is actually doing a Q&A session, and so I like to leave a lot of space at the end for Q&A. Yeah, down in the front.
When you were describing the reduction in the number of alarms, were those for the scribe service itself that you were working through, or was that one of the customer services that was using scribe?
This one? Yeah, so this is for scribe itself. The question was, when we were working through and reducing the number and dimensionality of our alarms, was it for the scribe system itself or for customers? The way that this alarm works is we measure latency from the customer perspective and then raise an alarm on ourselves. You over there?
You mentioned Scribe, and Scribe isn't deprecated GitHub repository. Does that mean it's not deprecated anymore, or what's the status of Scribe?
So he's asking what the status of Scribe is, because if you go to the GitHub repository for Scribe, you'll see that it hasn't been updated since, 2011 or something like that. Yeah, Scribe isn't deprecated internally. 2011 was a different time. I'm just going to leave it at that. Yes?
So you mentioned the not being afraid to delete alarms means that sometimes people delete the wrong alarm and miss something important. How do you work to get a culture where it's okay that sometimes happens?
So the question was, when we delete alarms, sometimes we might delete an alarm that we actually needed and didn't realize it, and how do you work towards a culture that like lets that happen? We're lucky that Facebook's culture kind of already permits that, and so that was part of why we were able to do that. As far as working towards it, like, it's really measurement. Like the talk earlier that said that like measurement influences your company culture, right? Get serious about this. Like, explain that an alarm that fires and 90% of the time, and this is a real case, we had an alarm that 90% of the time it fired, there was nothing for us to do. Measure it. Figure out like how often you use these alarms and just continuously adapt to it. And you will make mistakes, and I'm afraid I'm not wise enough to figure out how to make it okay to make mistakes inside a company. In the middle there.
Can I follow up on that? What is that magical threshold of signal to noise ratio that you found effective with your company? Like 1 to 1, I mean 90% is way too noisy, but if it's successful, let's say 75% of the time, is that good enough?
It depends, right? Like there's so the question is like what's the signal to noise ratio? Like how much noise in your alerting can you tolerate? Did I get that basically right? And so on Scribe and the other teams that I work with now on the monitoring team, like we strive for 100%. It's an evolving goal. Like we don't always get there. But other teams might be okay. Like if their service is really only used during the day, for instance, because there are systems that are only like stressed during the day, it might be more acceptable to have a more noisy alarm because you prefer that like people are able to use your service than let things go unnoticed. I kind of think that an alarm that is useful but isn't like tuned correctly is really more of an indication that you need to learn what it is about the system that you're actually trying to measure. It's more sort of like a mismatch. Way in the back there.
So you mentioned that you moved your reactive alerts or got rid of them altogether, but they were there probably because they had some type of business value in the first place, but they're probably not valuable enough to call somebody in the middle of the night. What do you move those to in terms of making sure they're still there, handled by the business in general?
Okay. So the question was, for the reactive alarms, we wound up deleting all of them. But they obviously had some sort of business value at the time that they were created, and like, how do you handle that and still track whatever business value those things represented at a point in time? So in our case, we found that virtually all of these alarms that had been created over a period of many years actually measured things that were no longer valid in the state of the system. Like they didn't actually track anything meaningful, so they were just spuriously firing. And for the case where they did have some business value, what we wound up doing was just making sure that we had it on a dashboard so that we could know when something had gone awry. It wasn't necessary for us to track it and fully follow down on every instance of the condition being violated. Down there?
So it's really great that you're using your dashboard as a debugger. I was wondering if you also looked at, once you have an alert, how much time it actually it takes to know what's wrong.
Okay.
And if you do anything to make your dashboard address that.
Okay, so the question was, once you start using your dashboard as a debugger, how do you measure that time from getting an alarm to time to identifying the problem? Is that the?
Yeah.
Okay.
Did you measure that and using your dashboard as a debugger?
We wound up not measuring that. We were in such a state that it was not meaningful to measure that. But it is absolutely an interesting thing to measure. If I were to measure it today, I would probably do it subjectively rather than analytically, because if you do it numerically, then you have to click a button when you start debugging something and then click the button when you're done. And I don't know, at 3 in the morning, this is my canonical case, at 3 in the morning I'm probably not going to remember to click that button. So I'd probably just sort of say it took maybe 30 minutes, and then you just kind of note that in on-call reports and things like that. And then you can go back and look over it maybe semi-annually or something. If somebody's raising their hand, I can't see you. No? All right, fantastic. I think we're done. Thank you.